Again, you're seeing a rational, and you're going to use partial fractions to do it. And let me go through that with you. Again, a little more difficult, but we can certainly get through it. So let's do one step at a time, all right? Let's go to the whiteboard. And I want to point out, when you're looking at a problem like this over here, a mistake students often make is not following the steps. And the steps for partial fractions is, well, the degree at the top, let me write this down for you, is degree 2. And the degree at the bottom is degree 2. And so what I'm going to do is, I'm going to do a long division. And let me put that down for you. So I'm going to take x squared plus 4x plus 13, and I'm going to divide it into 2x squared plus 8x plus 5. Well, that's going to be 2. And what do you get? 2x squared. Let's see, you're going to get 8x, and then 2 times 13 is 26. All right? That's not too bad. So what do you get over there as a remainder? Well, the x squareds disappear, the x's disappear, you can get minus 21. So this 2x squared plus 8x plus 5 over x squared plus 4x plus 13 is actually the same thing as 2 minus 21 over x squared plus 4x plus 13. Well, I still got that rational to worry about. I'm looking at it, and I'm starting to realize it's an irreducible quadratic. And let me just review that with you. I'm looking at the discriminant, which can be 16, and it's going to be minus 4 times 13 now. And certainly a negative radicand, so it's irreducible quadratic. So let me get my eraser out, and I'm going to erase my thing over here. And what I got to do is I got to complete the square. And they were pretty kind about it, because it's an easy completion of the square problem for me. This is x squared plus 4x. Half of 4 is 2. When you square 2, you get 4. But I do see a 13 there, so I need a 9, because 4 plus 9 is 13. Let me keep rewriting this. This is 2 minus, there's a 21 here. This would be x plus 2 squared plus 9. I like to pull out the 9, because I'm recognizing this something to do with arctangent. It's going to be 1/9. You know what? Let me put 21 here. And that's going to be times 1. And this is going to be x plus 2 over 3 squared plus 1. All right, this is the place I want to be. All right, so what I'm going to do now is, I'm going to reduce the 21 over 9, by the way. I'm going to divide by 3. And that's going to be 7/3. I'll write that down for you. All right, we're going to integrate now. And we'll be integrating this over here, which is 2x squared plus 8x plus 5. And that was over x squared plus 4x plus 13 dx. And it's going to be a simple integration now. It's going to be the integral of 2 dx minus 7/3, the integral of 1 over x plus 2 cubed squared, I'm sorry, not cubed, over 3, this quantity squared, plus 1 dx. Well, the first integral is really super simple to do. It's simply just going to be 2x. The next one, let's write this down. I'm seeing 7/3, I do see that. But what I got to do is I got to do a u substitution, at least in my head, but I'm going to write it down for you. My u would be x plus 2 over 3, so the du would actually be 1/3 of a dx. You know what I'm going to do? I'm going to erase this over here. I was premature, I'm writing that down. And I'm seeing the 1/3 dx now, and I'll point out what I mean by that. I'm seeing it here. I'm seeing that. So what do I say? I now see a 7. And I would see 1 over u squared plus 1, which I know to be the arctan. The arctan of u, but what's my u? It's x plus 2 over 3 plus c, because I removed all symbols of integration. Again, my recommendation is to always look at the key. When the key, you're looking for finality in the key, and you want to make sure that what you're seeing over here is what I'm presenting to you. Thank you for your attention.